Hi everyone, this is Radhakrishna. In this video, we will be talking about NASA ISRO Synthetic Aperture Radar, which is also called as NISR, which is being made by both NASA and ISRO together. What is the status? And also, I have for you all a 3D scale model of NISR satellite. So, NISR is an Earth observation satellite, which is most expensive Earth observation satellite. This is a flying bat in space. So how it observes Earth is similar to how bat observes its boundaries. So bats emit sound waves, and based on the reflected sound waves and based on the time delay, they know how far is a boundary. So this actually images Earth in a similar fashion. This uses L and S band electromagnetic waves instead of sound waves. Okay, so these are microwave radiation in the electromagnetic spectrum, and in this whole satellite, this is the most important structure of the satellite. Here we are having L and S band electronics, everything that makes RF waves and also processes and receives and takes the data, process the data, everything is here. Okay, now we have here two big solar panels which accumulate solar energy in space and power the whole radio frequency electronics and everything like that. Over here we have a small cube which is the spacecraft bus, which actually houses the EPS system and other processing logic computers and all that, right? So this is the main spacecraft bus. Now the other important part of this whole satellite is this portion here and this antenna, right? So this antenna is a reflector antenna. So this is a radar reflector antenna, and this is the boom that connects the radar reflector antenna. We'll talk about this in detail, but you can also observe this part over here. This is the small antenna over the radar reflector antenna. This is GPS antenna. For this satellite to know where it is in space, right, it has to have some idea. Just like your mobile knows using GPS, the satellite also uses a GPS antenna, right? So then it knows where it is in space. Now, well, let's talk about this part, right, this antenna. So what happens is this antenna actually transmits RF waves from the RF waves come from here. This antenna actually transmits it back to Earth, and when the Earth reflects the waves come back from Earth, and this antenna, it acts like a telescope. Basically it acts like a bucket, so it collects all the reflected waves and it focuses back to the feed, right? So it amplifies all the signals that are coming back from Earth. Now the concept of this antenna is similar to any dish TV antenna or any normal antenna. So in dish TV antennas, we've got a very big the antenna figure, like it's like basically a parabola or hyperbola, and then it focuses all that radiation that is coming back from satellite to a feed that is in front of it. This antenna is also similar to that, right? So, but when you see this 3D model, what you can see is this antenna is almost as big as the satellite structure itself, right? And the problem with this big structure is basically launching. If you pack all this in this mode in a launch vehicle, it's going to be very delicate, and it's also going to be very fragile, and probably the launch vehicle will not even support this big payload. So what will happen is this boom will actually fold, and this antenna is actually made with a mesh material. So this antenna, when it is in the launch vehicle, it's in a stowed configuration, right? And when it goes to space, it actually destows, it actually unfolds and becomes this antenna. So now what is happening is the whole structure of the satellite is actually going testing in India, right? And here the S band electronics are made by ISRO and the L band electronics are made by NASA, and this antenna is also coming from NASA. So what they have observed is, when this antenna is in stowed configuration, the temperature ranges are more than what they anticipated. So for making this antenna to embrace the temperatures that are going to be coming in the stowed configuration, they figured out that they need a special coating over this antenna, and so they have removed this antenna and they have taken it back to JPL for the special coating to be done, and that's going to come back and probably get integrated to this main structure in some mid or April end. Only then, after the integration, they will actually do another rounds of testing and they will come out with a launch date. So we all have to wait till this antenna comes back and gets integrated with NISR to actually know when NISR is going to launch.